We have a couple excellent learning tools right in front of us right now, and one of them Noyes put together for us, and it shows all of these high performance details that you want to see in a zero ready or zero energy home. And so one of the ones I really want to point out, which I think is fantastic, is this raised heel truss detail. And so what you can see is you've got a good distance from the top of the roof to the top of the wall that we can fill with insulation. And there's a ventilation cavity that's able to fit in this top inch, inch and a half or so. But here we've got a good 8 to 10, sometimes depending on the size of this raised heel, 12 to 18 inches even, of insulation value. If we look at the typical newer home model, which we also have right here, you'll see what usually happens. You get this compression where you don't have any insulation down at this edge, and so that ventilation cavity that's required comes down and your insulation essentially goes to zero. And so that may not seem very significant, but when you remove all of that extra insulation from that heel of the truss, from around the roof of a home, that whole perimeter, you can take that insulation value down 30%. So everyone's like, oh, I've got R38 or R40 or R50 in my roof. Well, we have to take a 30% reduction if you have this typical truss detail. So that's really huge. Noyes homes, these zero energy ready homes, they're typically saving about 40% more energy than these new code homes. And one of the high performance details that they're using is also called airtight drywall. And so what they're doing is they have this foam gasket that they put in. It looks like a sill sealer for some of you I've noticed that in the base of concrete walls, or top of concrete walls at the base of your exterior structural wall. But we're using that on the interior and at the top of the wall plates to create this airtight drywall detail. Then they'll also place drywall screwed underneath the truss and do what's called a blackout air seal, where they'll turn off the lights upstairs in that attic space and then look around and seal all the spots where you see light. So it's called blackout. So there's light down below you, but no light where you are in the attic, and you just go and foam seal all those spots. So between this blackout detail that you'd have on the ceiling and then this air gasket, they're getting ACH 50s, the air changes per hour under 50 pascals of negative pressure, down to 1 to 2 range. I think their average here is about 1.3 ACH 50. This typical home is going to have an ACH 50 of maybe 10 or 12. And so you're about 10 times more airtight than a typical home. That typical home is going to lose 10 air volumes typically a day. And this home is going to lose more like 1 just through air leakage in the building. Other really cool difference, one is just advanced framing. So you're going to have, if you notice, this whole model is bigger than that one. It's because we have 24-inch on center, so they have 2 insulation bays. This one's 16-inch on center, and there's more framing, across. If it were a 4-foot distance, you would have had another, another 2x6 here. And that framing's not as insulative as the insulation that's between the cavity. So we're both wasting material and we're less insulative. So this is just a higher performing model simply because it has less framing in it. And if you can use less framing in Oregon, which is seismic zone D, you can pretty much use less framing everywhere. So that's another really important detail. I also want to point out that if you look at the insulation, you'll see it's nice and continuous here. And that's really easy when you use this blown-in wall insulation. So we'll call it blown-in bib system. And they're essentially using this kind of spidery fabric that you might see at the bottom of a box spring mattress or something. They'll staple that over the framing and then create these little holes and stick in or tubes and blow in insulation. The cool thing is it fills that entire cavity. And so you wouldn't be able to see that it's filling all around that plumbing, and it does. You wouldn't see it would fill all around the electrical line, and it does. Here, what we're doing is a more standard, inferior, standard batt insulation install. It's really, really hard to do this perfectly, but in a perfect world, you'd have fluff the insulation around that pipe, you'd fluff it around this electrical line. That's not how it actually gets done in the field. It really does get done like this, where it's just stuffed in and stuffed behind things. You lose about 30% of the insulative value of that insulation when you compress it. Then we also have these gaps where it's cut short, just by human error. Sometimes it's cut long, but it gets compressed and squished down. But you have these gaps at the top, at the bottom as well, and you can get what's called wall washing, where you have a stack effect behind that insulation, and you get airflow moving through the insulation, even if there weren't an air leak in the wall. And so that also reduces the insulative value of the wall, and it creates this kind of drafty wall syndrome. So it just takes a little bit of a lack of attention to detail, and you can have a pretty poorly insulated home in that typical newer home detail. Whereas here, we've got an airtight, continuously insulated, more material and energy efficient details. So add up all those details and you get this airtight, super insulated, zero energy ready or zero energy home, depending if you add the solar panels or not. It's a pretty outstanding high performance system. Okay, so we've got the Mitsubishi heat pump outside. And one thing I'm noticing is it's really, really quiet.
Yeah, so a lot of times when we think about these outdoor units from an air conditioner or a heat pump, if we've had them, you think that you have to be like yelling, or you want your windows like to be far away from it because it's going to be so loud all the time. So we just kicked this thing on, and it's going on pretty high speed right now, and it's still really quiet. So you can enjoy all the time out on the patio here, entertaining, and not feel like you're competing with it if it is running, when it does need to run.
That kicked on air conditioning unit that we've maybe grown to dislike over the years. And so you mentioned inside that it was a variable speed motor, and so it's similar out here, and my understanding is that's an electronically computated motor, so an ECM motor. I think of it as like turning the dial on a stereo. You can kind of turn it up and turn it down as you want, versus the old school, the pulsating ones, where you basically have the push button, like stage 1, stage 2, stage 3, and they're quite a bit different in their energy consumption. And so this would allow you to use a little bit of energy, or essentially as much as you need to push the air around.
Yeah, that's again a great explanation, Stefan. And what's I think really important about that, especially in our climate, Portland's a fairly mild climate, is a lot of times we only really need a little bit of heat or a little bit of cooling. So when we get into what we call shoulder seasons, kind of not the peak of summer, not the peak of winter, a lot of times a typical system is just going to have way too much for the house, and so it's either going to be blasting way too much cooling or way too much heat. And it's really inefficient and it's really uncomfortable for the occupants. So by having this variable speed system, we can actually be producing and delivering the right amount of conditioned air and the right temperature to the home, regardless of the time of year.
Fantastic.
Another nice feature about it is it's really quiet, but it's also, I don't know, maybe a quarter the size of a lot of the outdoor units you'd be used to seeing. So we're actually able to install these on the side of homes now. This was one of the first ones we installed, and we put it on the back of the home, and it's almost kind of nice for us on our model home here to be able to have people hear it and see it. But because it's so small, we can still install it on the side of the house, out of the way for everybody, and have plenty of room to walk past it. With a traditional unit and a subdivision with kind of typical setbacks and zoning, you can't do that. So it saves space, it saves energy, it saves money, it's quiet, it's comfortable, it's just an outstanding system.
I can tell you're a big fan. Yeah, and it's literally 1/4 the size of what you would typically see. All right, Mike, let's talk a little bit about some of the specific design considerations now that we're looking at this home from the outside. Maybe we could talk about some of the bits with the siding and what you do there from a durability perspective.
Yeah, so we're in the Pacific Northwest here, and as we know, summers are beautiful. We're standing out here in sun and just kind of blue skies, but it's not like this all year round. We get about 40 inches of rain every year in the Portland area, and we want to make sure that we're planning our houses so that they can be resilient and durable in the midst of all that. Typical siding, a lot of times we refer to it as cladding. It's just, a covering on the outside of the house. A typical siding assembly, even if well installed, is going to only hold out about 90% of bulk water. So if we're talking about 30 or 40 inches of rain, and we're saying we can allow 3 to 4 inches of water to get behind that, behind the siding, that's not very exciting as a builder or as a homeowner. So there's some house wraps that exist that can help drain some of that out to some extent. But there's a kind of a best practice system that we employ, and it's called a vented rain screen. So what this vented rain screen does is it says, we know that some water is going to get past the siding no matter what we do. We want to make sure that that's able to drain and dry. So we have these battens here that create a 3/8 inch gap behind the siding, and we have a way for the water to get out if it gets behind there at the top of these flashings. And we have what you can't really see very well here, but you can kind of catch in some other details of the house. We have screens that allow for airflow to go through here. Now the bulk of the water is going to be able to drain down, and then anything that doesn't drain down is able to dry out as the air current flows behind the siding. So any moisture that ends up in the wall assembly, not just from rain, is able to dry very quickly and very efficiently. So it's going to make the home much more durable. Wood and water don't really mix very well together, especially over time. So we want to make sure we protect that. An additional benefit.
Terrible mix. And I just want to cut you off real quick first and point out something. You mentioned screens. And so I think what you're talking about is that bug screen at the base of the vent system and at the top, right? Because you're essentially creating this beautiful drainage plane where bulk water can dry out, or if you even have moisture build up in your wall assembly, I think you're pointing out that membrane is open, vapor open, so vapor can escape out, but it's waterproof, so water can't actually get in. And so you've got this great drying assembly that could also be an awesome home for little bugs. And it sounds like you've got a way to prevent that.
Yeah, that's a great addition and explanation. The screens prevent bugs from getting in and trying to make a home behind here, because it would be a great home for some bugs, but they still allow the air to flow and water to drain out. An additional benefit of this is that because the siding is able to dry properly, the paint is going to last longer on the siding. So it's going to be lower maintenance, lower costs and less work for the homeowner in the future.
Yeah, so you get less of that absorption and shrinking and contracting, whatever that would happen annually, and just a really great system overall.
So we also use cultured stone, artificial stone veneer products, and so below this area, we're going to have that installed here. And because of the way that installing it over vertical strips or battens isn't going to work well. So we actually use a different kind of rain screen system here. It's kind of like it's a mat, kind of a mat with some kind of woven fibers and curly things that hold it out and allow that drainage and drying potential.
Great.
So we've been talking about this vented rain screen and the screen system that allows the air to go through but keeps the bugs out. And this is an example of what we're using. So you have this fabric here that's going to make sure that no little insects can find their way through there. But then you still have all this great airflow potential and drainage potential through this. So this is an example of what you can't see here and up toward the top of the assembly. Some additional details that we use are these gasketed flashing products. So this blue plastic piece here is what we call a quick flash, and it allows us to waterproof and seal and air seal anything that comes out, any penetrations that come out from the house really efficiently. So what the siders have, this is still open and in progress here, is they're going to have this all taped in on the sides and across the top here, and then they're going to leave a little bit of an opening at the bottom. So if there was anything, any water or anything that found its way back there, it would still be able to drain its way out. But these flashing details are a cost-effective but really critical part to a durable and well-sealed home. So as we're walking through our subdivision here, we can see in the background this White House is one of our model homes out here. And up on the roof there, we have the solar installed that makes that home an actual zero energy home, and takes it from being just zero energy ready to actually zero energy. When we're looking at solar, we need to make sure that we preserve some roof space for that, and we keep different penetrations out of the way. So we have plumbing vents or roof vents that can be installed and can be a large problem for having those panels there. Can just really interrupt the spacing. So by making sure we keep those out of the way, we're able to install a nice clean system like the one we see. By making sure that we preserve and plan for at least a large section on every home, if not more than one section of roof space, we're able to take those homes from being just highly efficient homes to actually being zero energy ready, and then having the potential with solar installed to be truly zero energy.
That's really inspiring. It's so cool to see. It looks like about a 10 kilowatt, maybe 11 kilowatt panel system up there. And just thinking from like a resiliency standpoint, how fantastic is that to really understand that you can provide as much energy to the grid as you take from the grid annually with just something as simple as that on your roof. Really, really fantastic.
Yeah, solar has come a long ways, and it's much more affordable than it used to be. And so it's actually at the point now where if somebody's just looking at it from a dollars and cents standpoint and not thinking about the impact that they're having on the world, it makes sense. The math pencils out for somebody to either break even or save money. A lot of times now we're even seeing people saving money by installing this on the roof of their home.
Great. Love to hear that. Okay, so now we're here with Mike in my favorite room in the whole house. I mean, I'm a fan of good architecture. There's a lot of great architecture inside. But here we've got some amazing details. We saw some amazing details on the outside of the home. Really outstanding, high performance work happening in here. So I want to point out a few things. Mike, maybe you can walk us through as we talk about them. I see, of course, over here is where you're going to have that 97, 98% efficient Navian gas hot water heater. And then your rough-in pipes for your central vacuum system, correct?
Correct, yeah.
Well, as we move along, then I'm seeing like a little hole here for a fan. And let's talk about that for just a moment. Why are we going to put a fan there, Mike?
So we're in the garage, right? And what kinds of things go in the garage? Cars. Yep. Some cars are electric and aren't going to have the exhaust coming off of them, but they're still going to have, they're still going to be off-gassing things.
Now you might have your paint in here. You might have well, of course, if you do drive your car in, then there's like benzene and all these particulates that you probably don't want to send to your kids' bedrooms or whatever else. But certainly, we put all of our toxic garbage in a garage. Whatever we own, all the stuff that's got the skulls and crossbones, or even if it doesn't, the things that smell, I put them in my garage. I wouldn't put them in my house. And so it ends up here, right?
And so, like you said, we have all these things in the garage, and a lot of times the rooms above the garage end up being kids' bedrooms. So if you think about the potential for all the nasty stuff you keep in your garage to be just kind of finding its way up into your kids' bedrooms or into your house, it's not a very exciting proposition, right? So we do a lot of things, and we'll see some of it as we look around to make sure that we seal the house off from the garage very carefully so that they're separate spaces. But in addition to that, we installed this fan. And so right now it's the actual motor assembly's not here, but this is a fan that it's connected to a motion sensor. So every time somebody comes out into the garage or you pull the car in and out, this fan's going to turn on, and it's just going to exhaust the air from the garage. By pulling the air out of the garage, we're just helping ensure, even beyond the sealing that we've done on the house, that nothing's going to be going into the house, and even the air in the garage is going to be a little bit cleaner as a result.
So, you pull in the car, that's going to run for like 20 minutes. And so the car's off and all that exhaust is just being sucked out and going to the outside. And so when you open the door, it's not going to follow you in because the space is under pressure and all that air from the inside of the home will just rush out with the toxics out through that fan. That's really amazing. I'm noticing also a whole lot of air sealing and super insulation details. And maybe we can kind of look at a couple of those really quickly. So maybe point out some of the things that you think I might be seeing.
So we have a number of air sealing details like you mentioned. One thing that we have here that you don't see a lot of places is we have this self-adhesive flashing. Basically it's like sticky tape, but it's a little more durable than that, and the adhesive is going to be better. So we take this and we run it underneath the bottom plate of framing, which you can see bottom plates over in the corner there is an example on an exterior wall. But we run that underneath here and we flip it up, and then we run our drywall over the top of this, and that creates a really nice seal along the base of the wall here, and it helps ensure that there's no air leakage between those spaces. You can also see this kind of pink and white spray foam, and that's used to seal around anything like this electrical outlet or these different pipes that are coming from the house to make sure that we're airtight from the house to the garage. Above us, we also have this blown-in insulation, and typical insulation with bats that are kind of like big blankets that people are used to seeing just doesn't install as well and doesn't have the same insulative properties. So what we have above us is this really incredible amount of insulation. It ends up being about R59 between the garage and the house above. And that has the benefits of creating a more comfortable environment and being more efficient inside the home. But it's also something that's going to make the home quieter, because when the garage door opens and closes, or the cars are coming in and out, the people who are upstairs aren't going to be hearing as much noise.
And moving along this wall system, so you see the amazing air sealing details, super insulation details, and the clean air details. I'm also noticing there's a electrical line coming down from maybe the roof or something to this square box over here. Can you tell me what's going on with that?
Absolutely. So all of our homes are solar ready, and that's actually a pretty simple thing to do. To be solar ready, the main things that we need to do physically are we run this pipe, this conduit, between the garage and the attic space. And that allows a solar contractor to come and pull a wire between the two spaces. So we have this nice box here where they can come out with that wire, and then we reserve space on the panel here to make sure that we have room for additional solar to be installed. If you had a panel that was fully at capacity and you were solar ready but you couldn't actually hook it up anywhere, it wouldn't be very useful. So this pathway between the garage right near the electrical panel and the attic is what allows you to connect the panels, the solar panels, to the electrical panel in the garage here.
That's fantastic.
So I guess the challenging piece, we can talk about this. This is really fast and easy to install. Energy Trust of Oregon currently has some solar ready incentives that offset this cost or eliminate this cost ultimately for a home builder. Where the challenge comes in is not just running a path between the two places, but planning the roof and preserving the space properly for the solar.
So that's a really great point. So here in the Pacific Northwest, in our region, we're in a, very specifically because you're PGE, you have Energy Trust of Oregon as a potential partner in facilitating high performance details like this solar ready home. And everything costs a buck, Mike. So, with or without those incentives, how expensive is putting in something like this?
So the actual cost and labor that goes into this is just a couple $100s. It's going to depend on your contractor and how you negotiate that with them, but it's really not very expensive. It doesn't take a ton of material or time. So this is very low cost, something that everybody can and should be doing.
And so Energy Trust of Oregon will offset those costs for you if you're in that zone, and even if you're not, we're talking for a high performance detail like this, a couple $100.
Yeah.
So that's pretty awesome.
So in addition to our solar, we actually have all of our homes come standard for a car charging location. So this outlet is kind of the typical power for most cars. It'll have the typical NEMA 1450 plug that most electric cars would plug or would charge from. So if somebody wants to just plug in the cord that comes with their car, they can plug in and charge quickly here. Or they can install a mounted charging system here, and they have the power for it just ready and standard.
That's great. All right, let's maybe head into the rest of the house and dig into some of the other details.